I can't hear anyone.
It's 2 p.m. in Lagos, Nigeria, and welcome once again to another session of our data science webinar. My name is Jacob Agbero, and it's so exciting to have come this far in the internship. So today we would like to take a few comments on your experience with our 100 days of data science challenge that started recently. So if you are on Zoom, indicate by show of hand or drop a comment on our YouTube live feed to share your experience with us. So the time starts now. If you are on Zoom, indicate by show of hand. If you are on YouTube, just drop your comment. How is the 100 days of data science challenge coming for you from all over the world, from Lagos, Nigeria, from Kano, from Ogun State, from Accra, Ghana? We are waiting. Oh, comments are not coming yet. All right. So today, I hope we are all pumped up to learn from one of the industry experts in data science. And on this note, I would like to turn the program over to Amoye's program manager, Tobiloba Adejumo.
Thank you so much, Jacob. Thank you, everyone. Hi, everyone. Good afternoon. I am excited again to welcome you all to today's webinar. How many people are already online? I see we have people already on Zoom. I see interns on YouTube. Awesome. I am delighted to have you on board today, and you can use the live chat to let me know how you're feeling this afternoon. Currently in Lagos, Nigeria, the temperature is 29 degrees Celsius. Onyedikachi Adikwe is the first person this afternoon to join the webinar on Zoom. Thank you, Onyedikachi. I saw you when you joined the waiting room. Now, moving on quickly to our housekeeping rules. If you have questions, posers, maybe doubt or uncertainty during the presentation today, please wait till the end of the session in order to avoid lag or intermittent disruption. You can leave your questions on Slido using the event code 33345. Again, I repeat, you can leave your questions on Slido using the event code 33345. Now, without further ado, let's turn the table over to Dr. Anab. Dr. Anab Chakrabarti has been doing industrial research for more than 12 years. He did his MS PhD in electrical and computer engineering at Rice University, and afterwards did his master's in financial engineering at UC Berkeley. His work spans the telecommunication, finance, and manufacturing domains. Dr. Chakrabarti research publications and patents have been collectively cited over 1,000 times. Now, this is the moment you've been waiting for. Get your pens ready. Today's session promises to be super amazing. Now, over to you, Anab.
Thank you, Tobiloba. And I'll jump in because I have a lot of slides. Can you see my slides?
Yes, I can see it.
Okay, perfect. So you can see my slides and you can hear me. Let's get started. So the title of my talk is Data Science, Wealth, and Happiness. And I'll mainly be focusing on data science today. We'll talk about wealth and happiness if time permits. Like Toby said, we'll take questions in the end. So just to give you an outline, within data science, I'll talk a little bit about my research experience, not very much because Toby already described it. Then I'll dive a little deep into a pricing problem, a very exciting problem that I worked on. And I'll point you to some useful resources, which I think at this stage, the people in this program will find super helpful. All right. So my research experience, I did my PhD in electrical and computer engineering in 2007. Then I worked in telecommunications for 5 years. Then I went back to school to do a master's in financial engineering. Then I worked at a hedge fund for 4 years, and I've been working in a global manufacturing company for the last 3 years or so. The reason I'm telling you this is that the tools that I learned in college and grad school, the algorithms, the mathematics and the statistics, and the programming, what I found is that they are very broadly applicable. So data science is not a domain-specific thing. The tools apply across the board, and that's a very big positive for someone who's going out into the workplace. So let's keep that in mind. Moving on to the pricing problem. Pricing, as the name suggests, is a problem where we are trying to determine the price of something, a product or a service. For example, it could be the estimate of a home that someone is trying to sell or buy. It could be fee for guitar lessons. It could be the premium that one pays for an insurance policy. That's something we will dive deep into. And there are three notions of price. If you're a seller, then what matters is the cost of producing the good or the service. So what you charge is the cost plus some markup. If you're a buyer, similarly, what you care about is how much value does it bring to you? Therefore, economic value of customer. And this is not as crisp as the cost of providing service, which brings some interesting trade-offs into the picture. But nonetheless, the concept is there. Finally, market price. How much are others charging for a similar product or service? Now, if you were, let's say, selling something, you would want to know all of these three numbers, meaning how much is your cost, how much benefit is the customer or are different customers deriving from it, and how much are others charging. If you have all of these three pieces of information, then you can make an informed decision that does not charge a price that is too low, leaving money on the table, but also not so high that you are not able to compete. So this information is very important, and data science helps in answering this question. So let's look a little more closely at market price. How much are others charging for a similar product and service? Now, market pricing is a regression problem. Why? Because we are trying to fit a continuous variable. Price is a continuous variable. It can be any number. It's not a category or a cluster. This can be solved as a regression problem, but simple regression methods may not work well because if you think about it intuitively, let's talk home prices, for example. A bigger home generally costs more than a smaller home, but a bigger home in a rural area might still cost less than a much smaller home in a dense metro. So there's that. And for that reason, the approach that works well is to divide the data into clusters that are similar and then use regression within each cluster. Now, some models, sophisticated models, some ensemble models, for example. So an ensemble model is something that combines a lot of simpler models to build a complex model that can fit a complex surface. Things like random forests or gradient boosting, these are ensemble models, and they may be able to take care of this kind of regression implicitly. Now, let me give you an example of a problem that I worked on. This relates to catastrophe bonds. So let's take a step back here. What is a catastrophe bond? Let's start with insurance. We all know what insurance is. Home insurance, for example. Let's say you have a home and it's quite valuable and you want to protect it against disastrous events like fire, for example. Now, a fire can be electrical or it can start in the kitchen and it can burn down the house. And the homeowner, as an individual, does not want to be responsible for the financial loss in that situation. So the homeowner goes to an insurance company and says, give me insurance. And the insurance company might say, well, you'll have to pay me 3% of the price of your home, and I'll protect you against fire, against flood, and against other things. So the homeowner says, fine. And the reason this works for the insurer is that an insurer is insuring many homes. So they collect the premium from all of these homes, 3%, 3%, 3%. And in a typical year, very few homes actually go up in flames. Let's say only 1% go up in flames. So the insurer also keeps some profit in the process. And that's why it all works out, except if there is a catastrophe. For example, if there's a wildfire. If there's a wildfire, then in 1 year, too many homes can get destroyed, and the insurer may not have the money necessary to pay for all these losses. In this kind of situation, the insurer wants insurance against these large losses. It's sort of like the insurer is in the same predicament as the homeowner. And that's where things like catastrophe bonds come in. These are a form of insurance for the insurer. Now, let's say the insurance company has $10 million in their reserves to pay for losses. So if the losses are more than $10 million, the insurance company will have to pay for these losses, and it doesn't have the money. So it might buy a catastrophe bond that protects them from 10 million to $20 million. And this is what the rectangle, we call it a tower. This is what this tower represents on the right. The attachment is the value 10 million. The exhaustion is the value 20 million. So if there's a loss more than 10 million, but less than 20 million, then the catastrophe bond pays out. And on the left, you have a loss probability density function. As you can see, smaller losses are more probable, and larger losses, as they become larger and larger, they become more and more rare. And the idea is that by buying this sort of catastrophe protection, the insurance company hopes to stay solvent in a difficult environment. Here are some attachment, exhaustion, and expected loss probabilities for catastrophe bonds. As you can see here, the probability is around 1%. That's the level at which people seek insurance. Now, the way we model this kind of situation where there's a rare event and there's a loss is that there's a initial insured amount for the catastrophe bond, which is, let's say, $1 or 1 unit of currency, with a probability of small p, which is around 1%, there is a catastrophe. And in that case, the catastrophe bond issuer just gets to keep the premium. Whereas in 99% of the cases, there is no catastrophe, and the bond issuer gets to keep both the premium and the original amount that was insured for. So that's a very simple two-outcome Bernoulli model. This guides us towards a pricing formula. Now, if you think about it, the company that's selling you the catastrophe bond, they could just keep their money in the bank and earn some interest on it. Instead of doing that, they're selling the insurance company a catastrophe bond. So they would expect to be paid a premium that is at least equal to the risk-free rate that can be earned keeping the money in a bank or something equivalent. And this risk-free rate is the intercept of this regression line. It says ROL equals cost of capital. And beyond that, if there is an expected loss, then this catastrophe bond seller would want to be paid at least as much money as the expected loss. Otherwise, why would they be taking on this risk? So there's a 45-degree line, which represents the premium increasing at the same rate as the expected loss. On top of that, this company wants to be paid a risk premium for the volatility, for the risk that in 1 year there can be a very large loss. So all in all, the premium, which I call ROL here, is equal to the cost of the capital plus the expected loss, plus a factor that's proportional to the square root of the expected loss. This number is the standard deviation for a Bernoulli model. And this formula comes from something called the Sharpe ratio in finance, but we won't go into that. So this is an AI problem. We know the functional form of insurance premiums, and then we regress to fit it. This plot here, it shows you the regression, or it shows you the premiums for a number of catastrophe bonds that have been issued that were in existence in January 2012. And as you can see, the dots, they all do seem to fall on a line that's sort of like a curve in this region. About 1.5 years later, you see the same premiums, but you see that the premiums have gone down. What it shows is that pricing changes over time. What you can also see is that the fit is not very tight. In other words, it's not like they fit a line very well. So the basic logic works, but there's quite a bit of variation. And the reason this variation is that there are many types of risk. There's not just wildfire, but there are hurricanes, there are earthquakes. And these different kinds of risks have different prices. The problem becomes really interesting when it becomes a high dimensional problem, and we have to infer the risk premiums of different kinds of risk. And that's how we solve it. Now, another fascinating thing that you'll see if you look carefully is that there are some points which seem to lie under the y equals x line. So it seems like the premium is less than the expected loss. And what this shows is that data cleaning is very vital. These data points are clearly wrong. What could be wrong? Well, the data may have been entered wrong or saved wrong, or it could be that the expected loss of the rate online is recorded incorrectly, or there's an incorrect formula. What you will find if you go into a career in data science is that data cleaning will take much more time than it is given credit for. So that's something else to keep in mind. That's totally normal. All right. Now, let me talk a little bit about the current focus areas in data science, because when I started doing data science, even the term wasn't very popular. There were engineers and there were statisticians, and they were doing very similar work to what data scientists are doing today. But the problems have changed, the terms have changed. As of today and looking forward, I believe some problems that are going to be in focus are tasks that humans can do, but machines don't do very well yet. For example, synthesizing logical conclusions from large interrelated bodies of information. And these can be complex questions, but questions that a human being could answer with the help of a search engine and given enough time. Another problem is learning to reason logically. For example, excelling at a human IQ test, or let's say passing a medical certification exam. Those are quite hard. They require not only an understanding of natural language, but also contextual information from complex domains. In terms of tools, I believe that graph neural networks are quite important, and they're going to be increasingly important as time passes. These are a broad generalization of convolutional neural networks and recurrent neural networks. You're probably familiar with convolutional and recurrent neural networks. If you're not, you'll certainly encounter them. So a graph, a convolutional network, it takes a grid, like an image, and it performs operations like identifying objects on a grid. But the information is in the form of a grid. And a recurrent neural network is something that deals with sequences of information. It could be a time series, or it could be a sequence of words. If you take these two concepts, the time evolution and the grid, and you make the grid irregular and still keep the time component, you have a time evolving graph. And that, I think, is a very powerful concept, very general concept, one that can lead to answers in many domains that are very useful. Security and privacy have always been important, and they will continue to be important. And finally, the ethics of AI. AI is power, and I don't see work on security and ethics to stop or to diminish at any time in the near future. Now, let me point you to a few useful resources that I use in my learning. So a lot of data science happens in Python. If you become a data scientist, most probably you'll find yourself doing things in Python or interacting with Python in some way, shape, or form. The book that I found best for this, there are other books. It's not like this is the only one, but this book is good for Python programming. Python is a very versatile language. So depending on who wrote the book that you happen to be reading, the book may teach you a lot of things that are not applicable to data science. For example, it may have to do with web development or other things. But this book teaches Python from the perspective of data science. It's just one or two chapters, but it does a good job. And then it talks about NumPy, which is like a library that data scientists use very extensively. It's much more efficient at dealing with numbers and in particular with vectors and matrices than native Python. This book has an excellent introduction to NumPy, but also has an appendix that looks at NumPy's internals. I highly recommend them if you're going to become a data scientist and use Python. And finally, Pandas, which is a library for dealing with data frames and tables. The author of this book is the creator of Pandas, so there's no better book for Pandas than this one. Moving on, if you're thinking about applied machine learning, this book is my favorite. It deals with two libraries, scikit-learn and TensorFlow, both of them very popular for machine learning. And I think this is one of the best books for learning about these libraries. It has a lot of code that you can just type and it just works. And it has very insightful exercises, and the author will walk you through all of that at a very manageable pace. The book also goes into quite some depth about Keras. This is my second favorite book on Keras. The reason it's my second favorite is that my favorite book is by the creator of Keras, this one, Deep Learning for Python. So if you're going to use Keras, which uses a couple of different backends, I believe, not just TensorFlow, and I highly recommend the examples in this book as well. Very well written. Finally, if you are going to build large-scale data science systems, you run into considerations of scalability, reliability, and maintainability, which this book emphasizes and discusses in quite some detail, talking about the design and architecture of several large systems. These considerations, architectural considerations, become more important than one initially realizes. If you're starting out, these will not seem like considerations. But as time evolves, all of the big companies in the world that are using very large amounts of data struggle with these on a regular basis. Now, I have not mentioned books that do with theory. There are too many and depends on what you're focusing on, but there are quite a few good ones there too. I'd be happy to share them if someone's interested. Now, moving on to wealth. Seems like we have time. So how does data science relate to wealth? And let's start with a book that I read several years ago. It's called The 10 Roads to Riches. And it's a somewhat humorous book. And it's not an exhaustive list of ways to get rich. There are not just 10 ways to get rich. There are many ways of getting rich. But when I read the book, I found that there are 3 sets of paths for becoming rich. One set of paths is about realized talent. For example, if you build a successful business, then you can become very rich. For example, Jeff Bezos, he built Amazon. Or if you're a skilled inventor or author, like J.K. Rowling, she wrote the Harry Potter series. So anyone who's very talented and very passionate about putting their talent to use and meets with the right opportunity, they become extraordinarily rich. That's not a path that everyone is guaranteed to achieve. In fact, very few achieve it, but it's a legitimate set of paths. Another set of paths is wealth from the wealthy. I think this is the part where the book is humorous because it says there are paths like marrying a wealthy person, which I'm sure there's some skill to that, although I'm not the right person to help you in that department. And the final path, which I think applies to most people, is work hard, save a lot, and invest wisely. And I think data science can help you quite a bit if you want to go down this path. So let's talk a little bit about the journey of wealth. Being a data guy, I look at charts and graphs all the time, so I'm going to draw a chart for that. Now, on the x-axis, you have years. You were born at the origin, and your wealth is on the y-axis. There are 3 stages of the journey. There is dependence, when we are living with our parents or guardians and we are acquiring knowledge. There is employment. And finally, there's financial freedom or retirement. Now, the dependence phase is one where we learn skills. Our wealth doesn't typically grow unless there's a gift or an inheritance, or if someone takes on a large student loan, then their wealth can go negative. But by and large, this part is not where we make money. This is the part where we acquire skills that will enable us to make a lot of money. And learning data science skills is just one way to go down that path. Now, how much do we earn in a job? What I find by observing is that a skill set that is A, hard to learn, B, takes many years to learn, and C, is in high demand, it fetches a high price. You will see many people who work very hard for very little pay, and they deserve our respect. Their skills are often not specialized enough, which makes them replaceable, and the forces of demand and supply dictate that they don't get paid very much as a result. Now, data science, if you want to learn it the right way, it is very hard. It requires not only learning simple tools or methods, but it requires learning a lot of rather sophisticated concepts. I mentioned mathematics, linear algebra, statistics, programming, algorithms, complexity of algorithms. As you dive in, you'll find that it's a very extensive set, which takes a long-term time to learn. And once a person has learned that, that person becomes very hard to replace, which sets a person to earn a lot in their job. Now, let's move on to the next step, the employment step. How much we earn does not really contribute directly to our wealth. How much we save contributes to our accumulated wealth. But how much we save cannot be more than how much we earn, clearly. And how much we earn depends on the skill set that we have, like I just talked about. So here, if you assume that a person's earnings grow and savings grow with time, then the accumulated savings would be like a parabola. It would grow over time, and then gradually as we invest it, it would grow some more. And finally, in the financial freedom stage where we are not earning anymore, we are simply spending the money that we have and the money that we are investing. Now, this curve is a little bit misleading towards the end, because if the investment returns are high enough, then there's no reason that a person's wealth has to go down. It can keep on going up until the end of years. So that's the general picture. Let's take a look at one specific person, Warren Buffett, who's a very rich person. And you might wonder, why are we looking at a multi-billionaire? Like, this is so far from my life. The reason is that his life has these three stages. Up until age 20, he had very little money. He grew up in a sort of a middle-class household. He wasn't very poor, but he wasn't also very rich. And then he acquired skills. Let's move on to the next slide. Then he acquired skills from age 20. By age 20 or 25, he had acquired enough skills that he was a very good analyst, investment analyst. And he managed money for other people from age 20 to 40. And starting from around $10,000 at age 20, he had, I believe, close to 25 million at age 39. And beyond some point, he just said, I don't want to manage other people's money. And that was his retirement phase. He continued to manage his own money. So dependence, employment, and financial freedom, and he has a couple of $1 billion. Let's look at the rate at which his wealth grew during the employment phase and during the financial freedom phase. If I draw some lines, and some lines seem to fit the growth of his wealth quite well, it seems like while he was employed, every year his wealth grew at roughly 55% annualized. Not only was he investing at this stage, but he was getting paid by other people whose money he was managing. And in retirement, he was earning roughly 19% per year. So your wealth should have a typical trajectory if you keep on earning and then you retire and you keep on investing. But most of us will not become billionaires because these numbers are not realistic for most people. So, what is realistic? Um, well, if I assume that I join my first job at age 25 and I retire at age 65, and my starting salary is 100 units. Units could be anything, it depends on which part of the world you are living in. And let's say the ending salary just before retirement is 300 units. And let's say a person saves 20% of their income and they earn an investment return of 10%. Buffett had 19%, but I'm saying 10%. Even 10% is not low, but it's also not super high. If you run these numbers, and I ran these numbers in Excel, what I found is that if the starting salary is 100 units, a person at age 65 has 142 times the starting salary, which is enough to retire comfortably in most environments. So that's I found these numbers interesting, and I wanted to share how if you went into data science and did most things right, money would be one thing you probably would not have to worry too much about, and you could actually help others. Finally, all of this money and all of these things, they make sense in a broader context, the context of what I call happiness, but one could name it differently. Happiness has to do with fulfillment and satisfaction. We're getting a little bit philosophical here. So if we take a step back and ask, is data science right for me? Notwithstanding the money, notwithstanding the technical aspects, there is a very interesting concept, very useful concept called ikigai, which is great for evaluating whether a career is suitable for a person or not. And ikigai is a Japanese concept which literally means a reason for being. It says that we find satisfaction at the intersection of what we are good at, which is our talent, what we love, which is our passion, what the world needs. So, giving a broader ethical, moral, societal context to the work that we are doing. And finally, what we can be paid for, which is a practical consideration. Now, if even one of these things is lacking, these dotted lines, they show how a person feels unfulfilled. For example, if a person is doing everything except it's not something they love, then they feel comfortable, but there's a feeling of emptiness. Or if it has everything except the money, then it leads to delight and fullness, but no wealth. A lot of art tends to be undercompensated. So these are things to keep in mind. And if you are aware of these and if you see these concepts early on, then you can avoid a lot of angst later on in your career. Moving on, let's put career and wealth in the context of happiness broadly. And there's this wonderful quote from Leo Tolstoy. He says, "All happy families are alike, but each unhappy family is unhappy in its own way." It's not an inspirational quote or anything, it's just an insightful observation. And I've pondered a lot on why he says that. And it seems to make sense, but why would this be true? And pondering on this for a while, what I came up with is that happiness is not caused by one thing. It's not like having a good career will make a person happy. If you're in very bad health, you'll still be unhappy. Or if you have great health but a really bad career, that will also make you unhappy. So the things that we need to be happy are there are lots of major compartments that, like, there's health, obvious, love, which tends to come from family and friends, respect, which comes from work, community, etc., and wealth, which is wealth. Now, this is not an exhaustive list. Some people have all of these, but they manage to make themselves miserable by having a bad attitude about life. There's a lot of work in psychology, modern psychology, about positive thinking, which shows how important that is. And all of these things are quite important. But I think the point to understand is how important balance is in life if we want to keep on doing whatever we are doing. It is counterproductive to pursue either work or wealth in such a way that it hurts some of the other most important departments that contribute to our happiness. And that's all I have today. I rushed through the slides a little bit because I wanted to finish them. I have a few extra minutes to spare, but I'm more than happy to answer any questions and talk to you in the time that I have. Thank you very much.
Wow, this was viscerally mind-blowing. Thank you, thank you, thank you, thank you, thank you, Anab. I could genuinely feel your excellence and passion as you poured out your art with utmost sincerity to help and inspire. Even if I had brought my largest or biggest cup, Anab will never be affected because his well of wisdom never stops flowing. It looks like we have some questions here. Let me quickly run through them. Yes, the first on my list is from Daniel. So what advice would you give to a data scientist transitioning into the field of financial engineering?
In financial engineering, well, that's a great question. I would say financial engineering is a fairly broad area. Try to think about, be a little more, um, explore the area a little bit. Try to find out what within financial engineering you are interested in. For example, are you interested in investing to make a lot of money? Are you interested in helping people figure things out? Are you interested in accounting? There are many different branches. Maybe your education will be about exploring those branches, but there are a lot of exciting things going on. I did mention AI and machine learning. I think people are realizing that these concepts of AI and machine learning are going to be increasingly important in finance and investing. And there's a lot of excitement and work around that. A lot of uh, people with data science skills, advanced data science skills, in particular graph machine learning, are being highly sought by major banks and investment firms. So the demand definitely is there.
All right, thank you, Anna. And before I move on to the next question, I have to read some of the observations from the interns on Zoom. So Wale Adelawa said, webinar took a little turn today. I love every bit of the slides. Oluwashayo Akinwumi said, that was really, really good. Ifeanyi said, this took an interesting turn. Thank you, Anab. So the next question on my list is from Ayotunde. How do we address books that are already outdated? For instance, looking for a book that teaches TensorFlow 2 may be difficult unless we decide to learn an old version of TensorFlow.
How do we deal with books that are outdated?
Yeah.
Can you read the last part of the question once again? I want to make sure I understand it correctly.
Okay, how do we address books that are already outdated? For instance, looking for a book that teaches TensorFlow 2 may be difficult unless we decide to learn an old version of TensorFlow.
I see. That's a good question. What I find is the best authors, they tend to handle this thing quite well. Like the book by Aurélien Guérin that I talked to about TensorFlow and scikit-learn. It's mostly about TensorFlow 2, but he also wrote the earlier book on TensorFlow 1. And he walks the reader through the transition. He talks about the old version, the new version, what has improved. He talks about how to install the new version, what if there are any dependencies, etc. And I think all in all, if you pick up the right book, it'll do justice to both the past and the present. I would recommend learning the latest versions unless there's a special need within your job, a legacy dependency, because these tools are constantly evolving. They become outdated quite soon. I hope that answers the question.
Yes, yes, it does. And so there is another question here from Shashank Subam from India. I have a classification problem, and there are two variables that are highly correlated, and one of those two has many missing values. What should be the approach in this case? Add or remove them?
So you have two highly
Two, var
correlated
two
variables,
highly correlated variables,
and you're trying to.
and one of them has many missing values. What should be the approach in this case?
So one approach would be to just think of missing values as an imputation problem. Um, if it depends on the kind of data also. For example, if it's a time series, and I mostly deal with sequences and time series, then there are strategies of imputation that apply specifically to time series. For example, you could take the most recent value. But in general, if you have something with a lot of missing values, in some cases, it's best to just either ignore that variable completely or to get rid of the samples that have missing values. In other cases, you can replace it with a median or a mean or some kind of measure of central tendency. But it depends a great deal on the problem. If your classification problem has a lot of features and you're just talking about two, uh, then unless it's super critical in the classification, you could get rid of it. But if it is super critical, for example, if that variable is above a threshold, your classification always gives a one, then maybe use some suitable default value for the missing values. I hope that answers it.
Okay, thank you, Anab. Another one here. What informed your decision to move from electrical and computer engineering to financial engineering? This seems like very different fields.
They are pretty different. And it's funny, it's a little bit like finishing. I first did my PhD, then my master's. And it's a little bit like finishing seventh grade and then going back to sixth grade. I'm a little bit like the Benjamin Button of education. I like to joke about that. But that's the thing about passion. When you really like something, it's very hard to deny it. I became super interested in financial data, and I continue to be interested in financial data. That is the reason why I went back.
Thank you, Anna. When you really like something, it is very hard to deny it. Thank you. The next one here is from Akakabuta Daniel on YouTube. How do we get these books, please? Is there a site you can recommend? Amazon?
Yes, you can purchase them on any site. I would recommend that you search for them on Google first. Some authors are generous enough to share a PDF on their website or somewhere. And they say if you really like the book, then you buy it from Amazon. Otherwise, you get the free PDF from their website. I have all of these, and I think I got them from, you can get them from any online bookseller.
Okay, thank
Highly
you.
popular.
Okay, and here's another from Emmanuel Dixon. How does a person who is still in dependent stage stay motivated during the process of learning skills, seeing that most employers out there will not be willing to employ such individuals yet?
Can you please repeat the question?
Okay, how does a person who is still in dependent stage stay motivated during the process of learning data science skills, seeing that most employers out there will not be willing to employ such individuals yet?
Well, I think there are two pieces to this. One is it may be possible to get unpaid jobs, and these jobs are great places to learn, like internships and things like that. Um, and then you can put it on your resume and move on to a paid job, etc. A lot of people do that journey. In fact, I recently helped guide an intern like that. And as far as staying motivated is concerned, I haven't had difficulty staying motivated when working on something that I really was excited about. If you don't feel that excitement, the chances are that there's something else that you will find more exciting. It doesn't even necessarily have to be within data science, although it could well be in data science. I met a person, for example, who was very interested in sports and sports statistics, and he wanted to learn data science to become a new kind of sports journalist. So, if that is what excites you, use the passion for that to fuel your need to learn this.
Okay, thank you. And you answer you give also answered this question by Shashank Subam. So he was asking, hiring managers ask for a lot of experience, even for an entry-level job. How can we manage to break the glass ceiling? So like you said, you can go and enroll for an unpaid internship and get that experience, right? Okay, so moving on very quickly, we have another question from Ifeanyi. What project can someone do right now to have a portfolio at each stage of learning?
I believe there are many projects on Kaggle which deal with various data science problems. If you're looking for specific projects, I would say combine, look for a few different things, and you could doesn't have to be something that fits all the criteria. Sometimes it just helps to start doing something. Reading through those books, typing out the code, running them. If you do that for a couple of months, you will become very, very proficient in data science. That will help you tremendously in interviews. It may not be something to put on your resume, but it'll lead to learning. If you're talking about projects, you would be well served if you find out an area or a problem that you're interested in, as well as pay some attention to what are the problems of the future, such as the ones that I mentioned: graph neural networks, knowledge graphs, uh, logic and reasoning. If you do something that's really cool and advanced, then that is something it gives you something to talk about in interviews, and it impresses people. It shows initiative on your part. Yeah.
Okay, yeah, thanks. And here's another from Wale. So how would you advise a graduate who started a data scientist job and thinking of going for an MSc, since most schools claim that they train students to become industry ready? Is it not better to remain in the industry and get better rather than quitting your job and going for a graduate program? Should I take that again?
No, I got it. It's a little bit situations dependent. So in my experience, what I find is that people grow in many different ways. But if you don't stay in one place long enough, you don't really grow within an organization. So there's growth that happens within an organization. There is a learning curve whenever a person joins a new place. It's a different environment. It does things differently. The culture is different. The values are different. The people don't know you as well. And as you stay in that place, the people get to know you. And assuming that you are a good contributor, then your credibility grows over time. So there is definitely some value to that. However, if you feel that it's not, you're stuck there, or it's not a good fit, then it may be a good idea to mm, go somewhere else where you believe that you would be a good fit. But as to the MSc versus specific job question, it's a hard one. Trust your judgment. I wish I could be more explicitly about that.
Okay, so before I read the last question, let me just take some of the observations on YouTube. So this is from Akinlade Olarenwaju. This is an inspiring webinar, great presentation. Thanks to the presenter and thanks to Amoy for the privilege to learn. So the last question is this: please, how can we contact you or reach you further after this class?
You can find me on LinkedIn. I'm on, you know, my first name and my last name, and I work in Hitachi. I think I'm the only person with my first name and last name in Hitachi.
Okay, it looks like we've covered a lot of the questions. Is there anything you'd like to say before a final wrap up today? Yeah, I'm so sorry. There is a question from Bruce, so let's quickly take that. I have been thinking of a project on sound, kind of an AI that inputs audio and can search for some phrases from a database or Google. Any idea?
Um, the biggest challenge in my experience with any project, even within industry, is getting data. So the way I think about these projects is because of my finance and economic interest, perhaps. You may have heard of the factors of production: land, labor, and capital, which go into producing things. In data science, the land is like the software and the hardware platforms. They're quite important. Labor is just you, and capital is data. And what I find is the rarest thing is data. If you can find the right data, then by all means go ahead and knock yourself out. Um, find Do the best project that you can, and it will really be something that you can showcase. But if you're not able to find data, I find that people can do things with simulated data and so on and so forth, but they're not nearly as impactful or as impressive as things done with real data.
Thank you, Anna. It looks like we've covered all the questions now. Let me see. We've covered all the questions now. Is there anything else you want to say before you final wrap up?
No, this was great. I hope it was helpful, and feel free to reach out to me. I love doing this, and thank you for the opportunity.
Yeah, thank you so much, Anab. Thank you everyone for being here today. Thank you, Anab, again. We appreciate you for being here. Thanks again for joining us today, and we'll see you another time. Bye.
Thank you, Toby. Bye bye. Bye, everyone, and good luck.
Thank you.